Hello everyone, welcome to the spotlight stage, the mini stage with the big screen, right? So hopefully everyone enjoyed the main stage presentation, and what you saw there was just a glimpse of some of the fantastic presenters and innovative demonstrations that you're going to see in 20-minute increments over the next couple days here at the Spotlight stage. I'm Mark Demers, I'm the host of the Spotlight stage. Pleasure to be here. A couple just quick housekeeping. You don't need those headsets, clearly, because you're hearing me, but if it's hard to hear, there are a few back there for you if you'd like. And then also, we won't be doing open Q&A, but all the presenters are completely accessible. You'll see them around here on the trade show floor or accessible right after their presentations that they'll be doing. So go ahead and approach them or go talk more depth at the demonstration stations that they'll lead you to. So by show of hands, who here likes magic? I mean, we're at the happiest place on earth, right? Well, this first presentation, I'm really pleased to introduce Mapping Made Magical. And our first presenters are Jim George, Principal AI and Data Scientist at SAS, and Lou Flynn, Senior Product Marketing Manager. They promised to show you some magic, so without further ado, let me turn it over to Lou and Jim.
Hello, can you hear me okay? All right, can you guys see? I know the text gets pretty small up there. So my name is Lou Flynn, and this is Jim George's. We've been working together for about a year now, since we started the SAS Models program. If anyone's familiar with SAS Models, Udo and Manisha did a really good job on the main stage earlier today to talk about our lightweight, industry-focused models that really do a great job of accelerating AI implementations at our customer sites. So if you're not so familiar, SAS Models, what they really do at their core is they connect to real-world data on production systems to help solve problems. We provide models and templates, frameworks, essentially model pipelines to help our customers find value from their data. So we take your data problems and turn them into value. You could accelerate time to value and maximize your ROI through pragmatic outcomes, right? Let's take a look at one example of that. SAS Medication Adherence Risk. It's an offering through the Models program that helps organizations within the healthcare sector, again, industry focused, because only half of patients take their medication as prescribed, right? That's a big problem. What we do is we mash their data through some model pipelines that provide predictions, analytics, and some insights. So managed care organizations could plan timely, targeted interventions. What does that mean in terms of an outcome, right? An already strained healthcare organization could save time, money, and ultimately save lives by providing patients with the care, the prescription, and the access to the medication they require to get better. So let's bounce that offering, that model, off of a framework that we use, the data and AI lifecycle. Where does this model sit, right? If you're not familiar with the data and AI lifecycle, it's a framework that we use here at SAS, where we can map questions about data through predictive models and ultimately out to decisions or insights where people can take action. So the medication adherence risk, or most of our models in that regard, if you bounce them off of this framework, they're model pipelines where we train on customer data and then we score or inference against that data and provide some reporting so people can make decisions off of the predictions from this model. So everybody knows that SAS has bleeding edge, highly efficient, mathematically accurate model training and model scoring, right? So from that standpoint, on the right side of the data and AI lifecycle, we reach terminal velocity pretty rapidly, right? But I know from experience, in my career, the biggest hiccup is usually from a data perspective, right? Data's dirty, it's not analyst ready, you're struggling, right? So how do we accelerate AI implementations if we're already at terminal velocity on the right side of the data and AI lifecycle from a data perspective? What about left of center? What about data to modeling versus just modeling and scoring, right? Jim,
Yep.
what are we doing to innovate with regard to accelerating the left side of the data and AI lifecycle?
Well, Lou, we're working on a product which is called Data Mapper Agent. We call it Mapper for short. Data Mapper Agent, a mouthful, right? What it's doing is going to leverage generative AI to make that left of center work an almost magical experience. What Mapper does is it automates the data engineering work that is needed to transform a customer's data infrastructure to the format needed by SaaS models and solutions like the medication adherence risk model. And I would like to show you some of that today. So what we have is going to show you is a demo. I know you're a really visual guy, Lou.
Yep.
And I want to show you how it's going to work, and we can then take it step by step and really get a good idea of what Mapper does. So let me click over to the demo. And I want to, before I start, I want to point out what you're going to see here is a user interface that's communicating with an agent, an AI agent in the background. So this AI agent can run also in a more autonomous way, but we want to have you experience this as a human in the loop so that you can influence the outcomes of the data mapping process and work together with the AI agent. But most of that work is going to be being done by the agent. And this is really something that a model we're really looking forward to building out at SaaS, and there's a whole roadmap around these agentic systems. So I'd love to show you this, but here's the user interface we're going to use for communicating with our agent. It's organized into two parts. On the left, we have what we call our guided workflow, which turns the mapping process into a 1, 2, 3 step-by-step approach. On the right, though, that's the real heart of this. This is a collaboration log. This is where we're actually communicating with the agent. It's telling us what it's thinking. We're going to tell it what we like to do, and we can work on that collaborating that way with the Mapper agent. So what we need to do to get started is we need to upload a source schema. We have our medication adherence risk model. We want to connect it to our existing systems. So we have our source schema. We have how the data is all organized in our company. Mapper also knows the organization of the data that the medication adherence risk model needs. So we're going to try to put those things together. So the first step is uploading the source schema. So I'm going to click Upload Source Schema. We can drag it. It's going to have it conveniently located on the desktop, include it, and it gets loaded in. If Mapper were working in a more autonomous way, that connection to the database might be just run in the background. But here we're doing it, again, manually, human in the loop style. We can see in the source schema there are a number of tables all related to medical claims in some way. We have prescriptions, diagnoses, procedures, drugs, patients, all of that information. And so what's happening once we've loaded in that schema, let me show you more details here first. We get column names, types of data, and most importantly, column descriptions. And what Mapper's going to do is going to say, I have this source schema. I'm going to look at it. I'm going to see how it's relating to my target schema, and do they match? And the information on the right is procedurally generated by the AI agent, and it says that there are 24 tables. They tell you what's in them, and this one sentence right here kind of summarizes it all. That says mapping to the target scheme is generally feasible for most columns as the key elements, drug codes, patient ID, claims ideas, therapeutic, all are present. So basically, Mapper's giving us the green light to go ahead. There are some caveats, and we're going to get to those on the next screen. But with that, the agent's already involved in the process. It's saying, all right, I see what you've got, I know what you got, and now I can make it work. So let's click continue to basically start the magic of the mapping process.
So what we're looking at here is we're taking a look at the customer schema, Jim, and then we're comparing it to a schema we have identified specific to this medication adherence risk offering?
That's right, Lou. Mapper is looking at the elements of the schema and deciding how these things are going to fit together. Basically, where are we have certain pieces there, what's the best fit, and for each element of the medication adherence risk model, we're looking to see which is the best match from the source schema for it.
But who's comparing these fields?
Well, Mapper's an AI agent. As I've been saying, it's doing the comparison for us. And it's pretty good at doing this. If we're doing this human in the loop, it's going to find all the obvious matches. Like, for example, this field prescription fill date. It says, there's a field called RX fill date in the source schema. That's an obvious match. RX prescription doesn't take an AI model to know those things are the same. Sometimes it's going to need to do some simple joins. So for example, you see therapeutic class code. It's going to need to join that with some other variables in order to make that mapping. But then if we go down here to this table and expand that out a little bit, facility stays, there's a couple fields there, facility admission date, facility discharge date, which Mapper's decided, I'm not going to make a mapping for that. Why not? Because there is no identical matching in the source schema for that variable. It's going to say, I don't have an exact match, and if you scroll up on the collaboration log, you'll see a message like that, but I'm going to leave that to not do that here. But it turns out that the information needed for these fields is actually in the data. We just have to know how to get at it. So let's take a look about why we might want to have the facility's admissions and discharge dates. What the medication adherence risk model is doing is saying, all right, I want to make sure people are taking their medicine. And when someone's in a hospital, we're going to be pretty confident that they're going to be taking their medicine correctly, right? Because they're under supervision. So what we really need to do is identify records that sort of indicate when somebody's in inpatient care. And there turns out there are records in the database, such as procedures and surgeries that are identified as being on an inpatient basis. So if we can find out when they're in the hospital, we can assign a facility admissions and discharge date.
But if you only have the events of these procedures, how do you figure out the admissions and discharge dates from there?
Well, the way I would doing this, if I were programming this, I would look for contiguous dates of events. Think about it. I have a date on one day, the next day, the next day, the next day. That looks like a hospital stay. So if I can identify these contiguous stays, I can take the first of that contiguous stay as the admission date and the last as the discharge date. Now, how do we get Mapper to do this? There's a variety of ways, but maybe the easiest is to simply just tell it what to do in the collaboration log. Since nobody likes seeing me type, I just had that on the clipboard and pasted it in, right? We're going to give Mapper instructions. Regenerate admission and discharge dates from continuous inpatient procedures and dates and surgical dates. Simple enough. Let's put that in and let Mapper go take it. So what's going to happen? Mapper is going to take that information, combine it with what it knows about the source schema, target schema, and recognize that it has the information needed to make the transformation, to make the assignment of those two variables. It says, I'm going to need to use multiple source tables and multiple source columns to get this information. And here's the transformation I need to do in order to make that happen. I'm going to find inpatient procedure and surgicals where the place of service code is inpatient, and it will go ahead and do the mapping. So what's really, I think, fascinating is I gave it kind of the gist or vibe of what I'm going to do, and it took that instruction and figured out the rest.
But how does that translate into action, Jim?
Right. It's probably easiest just to show you. So we've done our mapping. Let's generate the artifacts from that by clicking continue and going to the next step. And while it's doing that, let's just think about what we're going to get out of Mapper. So we have a medical adherence risk model. It needs several tables, patients, facility stays, drugs, and everything like that. Each of those tables can be created by Mapper as views to the source data.
So you're getting a view of data No data duplication?
Exactly. Remember, a view, SQL view is just instructions on how to read a data set, right? So what we're going to do is we can have the instructions for how medication adherence risk model can read that data and access it without, as you say, duplicating it, and having the medication adherence risk model have the most up-to-date data for all of its use, all of its needs. I think it's done generating. Let's take a look at some of this stuff. You know, a lot of these codes are pretty simple, right? You know, for example, this drug table is just a create view with a select statement. Sometimes we need to do some joins in there. Mapper is going to be really careful, by the way, of the code it's generating, that it doesn't assume clean data. So it's going to account for missing values. It's going to account for say duplicate data. It's going to add some safeguards about that. So why you sometimes see some decorations on the code. But probably the most important thing is to look at the facility stay thing, the one we kind of vibe coded. Here we have a create view with facility stays, and what it's going to do is it's going to select all of the procedure dates from the procedure file where service code is inpatient, all the surgical dates from the surgical table where the service code is inpatient, dedupe them, and then basically run an algorithm. How many of you have heard of gaps and islands? It's a SQL concept where you're literally defining contiguous dates. Mapper knows that. It's able to create this gaps and islands algorithm, which works as follows. I'm going to take all my dates and identify a grouping variable on them, okay, when they're contiguous. And from each grouping variable, take the minimum date and the maximum date and assign it to the facility stays. And we get out our variables. There they are, they're being assigned right there. So it's really quite amazing that Mapper has gone from just a gist of what we want to do to code, which is, I would say, skill level 5 type code. This is not something that people have off the top of their head, but it's generated that on its own and is allowing us to do that mapping process for the medication adherence risk model.
Cool beans, Jim. Simple, pragmatic, effective.
Let's get to the really cool parts. Mapper also has generation of this mapping schema. This is the seeds from which all of that code generation was taking place. If we were to rerun Mapper, we could make it use this mapping to generate code in other languages. If we want to use a different variety of SQL, we could have it generate Oracle SQL, or any type of SQL we want. We could generate SAS code. We could generate Python code using this mapping that it came up with. And that is the magic of Mapper. It's being able to use this information, figure out what we want to do, and generate it. Okay, but the schemas are really hard to read. What else do we get? We also get a document, which is summarizing the code that we just wrote. It's written in English language, it's marked down, it's all being generated from the mapping that we just generated, we created. It has the source and details, the target details, all the mappings that have been done, written out in English prose, the members, the join relationships, all this data governance information. It's amazing. All of these things can be generated by Mapper automatically, and we get out this information. I think I should mention that you should also use Mapper in a more autonomous way. It can be used in the background by our solutions and be able to install some of this information directly into your databases if you choose to give that permission for doing that. It can collaborate with other SAS agents and discover things about the data that, using the schemas and everything. And it can also be able to kind of increase the intelligence and use more compute time to actually figure out all the mappings on your own. We've actually demonstrated it where it does that whole process you saw from start to finish without me typing the clue. It just generated it all through it, figured it out from the schema. That requires an underlying reasoning model, and it runs a little slower, so it wasn't as fun to show you here. But it's really an amazing process. Lou, what do you think?
Jim, this is fire. Mapper, guys, have you seen that? Let's double click, because that was a lot, right? So SAS models, It's a program we're using to instantiate model deployment through ready-made AI models, model pipelines, accompanied with intuitive reporting to make more digestible, pragmatic decisions from your data, right? Left of center, where people's big problems usually lie, can be accelerated, leveraging the data mapper agent, helps you get going with your data in production faster. Again, kicking off through the SAS Models program. Look for it later this year as part of our aggressive roadmap strategy. Jim,
Well,
how can they move forward?
I want to just invite you all, if you have some questions, I would love to talk about it. We're over there in the models booth. You can't miss it, right? Look to the right, look to the left. Your left, and come and talk to us. We're looking for, answering questions and maybe even finding some early adopters if you're interested in a few months. So thank you very much for your attention. We're really excited about Mapper. I hope you guys are too.
Thank you so much.
Thank you, gentlemen. Hopefully you enjoyed that presentation. There's another one starting in approximately 10 minutes. We'll get the presenters here, get them mic'd up. So get yourself some water, relax, don't go too far. The next presentation, since we're sticking with data, is going to be about Data Maker. So you don't want to miss that presentation as well. Thank you. And remember to fill out the form in your app. Give us feedback.